G'day everyone, and welcome to my channel. So my name is Matt. I'm a design engineer by trade. I've been doing it since 2014, almost 6 years now. I started out in the medical and manufacturing space. I've worked in heavy industry design. I've worked in nuclear, which is my current job, and I've worked in the water treatment and process engineering space for a few years. So what I'm going to do today, one of my passions is to do design work for myself in designing stuff that I can actually use. So I've previously done things like small boxes to hold stuff. I've done things like tables, chairs, and have actually built some of them, which is pretty cool. I also sell my plans, so my plans are actually available on my Etsy store, which I'll share a link to in the description. Anyway, let's get started. So the first thing we're going to do is start out a new part. So I'm using 2018 just because I upgraded recently to be able to use the generative design function. I don't need that. Alright, so what I like to do when I'm drawing up a system is I like to actually work with sketches first. So we're going to start by saying we want to sketch on this plane. Let's say we want to... Let me get my tape measure out, which you obviously can't see. So about double that length there, so let's say 2 meters long. And then we work on that, so a meter, and a nice rectangular table. So that'll be the foundational drawing of our table. Let's just save this fella into... there's a few funny little projects in here, as you can probably see. That folder there. Alright, so I'm going to call this the basic dining table. Okay, so we're going to be working within the weldment area today. So weldments is this menu down here. If you don't have access to it, you can actually add it here. I usually keep weldments, sheet metal, and features as sketch available. At the very least, evaluate's also quite handy. Sheet metal obviously gives you access to the sheet metal functionality of Solidworks, whereas weldment gives you the access to the weldments. I use weldments quite a bit through my work, as I've done a lot of work with welded structures. So what we're going to do is we're going to work in a 3D sketch, which is my favorite type. So we've got this sketch as our bounding box, so it tells us how high we want it, how big we want it. So we can go... Now I've set my keys of my mouse. I've got a gaming mouse that I've actually used for work. So I've set up, we've got two keys. One set up to escape, which is going to do, so normally if you don't hit escape, you'll have the next line, next line, next line. So by hitting escape, you can actually stop the line. Now, one good thing I like to do is not rely on having everything geometry linked or everything with measurements on it. So we use constraints. And so we're using, in this one, we're using the equal constraints. So that will make these all equal, which makes life a... What the hell is it? Ah, weird. Solidworks does weird stuff like that sometimes. Yeah, so as you can see, we're sort of just doing, they all go together. So if we're going to do a tabletop, we want that to be, was my tape measure? I think it was about 800 millimeters if memory serves. Now, I don't work in inches because it's way less accurate. It's up to you what you want to use at the end of the day. What's that table height there? 730, that'll do. So we're going to minus a little bit of room because we're going to have some top on there. So let's go 650. And then we're going to convert these 4 lines into a sketch, which is something that's super handy that a lot of people don't know about. So this convert entity will actually bring that into this sketch. Now, what we're going to do is that's going to be the base frame of our table. Now I'm going to go to the top plane. Now Control 8's the functionality that I'm using here. So Control 8 does like a normalized view, so if you select the right plane, it'll default to that. As with the escape button, I've actually set that up to match one of my buttons on my mouse, which makes things a lot easier. And the other one would be that one, which is I've set for measurement. which, yeah, personal preference again. That's make life 1,000 times easier button. Rightio. So we're going to use that as the other dimensions of our frame. We're going to actually have a smaller internal frame, which will be inset at 15 millimeters off each side. And we'll call that a day. Actually, no, we're not. Yes, we are actually, because I'm going to use something else to set that geometry off. So structural member. Now, structural members is what sets up your weldments. So I've actually created a timber profile folder for myself. So I'll actually go through how to do that later on down the line. I know at my workplace, we have a tube stainless which suits all like your swage lock and your OD based tubes. So your gas lines, that sort of thing. The flat bar, I believe, is one I've got to set up still. So timber profiles is my own personal thing. So there's just a couple of common sizes that I use there. So we're going to use 90 by 30 as the profile. So we're going to build as you can see, this is the benefit to using something like weldments. It builds an outside frame. Now what we're going to do, there's a couple little tricks with the weldments, is we're going to rotate that through 90 degrees and we're going to set the profile by hitting locate profile off of that thing. So that then forms the outside edge of our bounding box. I'm going to hit go, and that's it. Now we're going to set this to oak, so it gets something of a timbery look to it. The next stage is we're going to put in some legs. So we're going to go legs 90 by 90. Now this is going to be a bit trickier, but we're going to be able to get this. Because these are going to be based on different geometry, we have to actually make these as separate entities. So we're going to do that. And then we're going to go new group, and that one. Select the wrong one there. Locate profile. Same again, we're going to just work through these 4 legs. Okay, sometimes it doesn't want to play ball. New group, that fella. And new group, and on that fella, and locate profile. So you can actually add extra geometry to this sketch once you've done this, so you can locate it temporarily based on something, and you can actually set an offset sketch, which I'm going to do in a minute. Now, what we're going to do, this is a bit of a cheaty sort of way to do it, but I'm going to do it anyway. So we're going to have like an inset frame that everything's going to be based off of. I've just realized I actually want to put something else into my frame, which is going to be a horizontal member that way. So I'm going to go back into that sketch. And we're going to go on the internal frame. There we go. Okay. Why it does that every so often, but that's alright. So we're going to do another back to the 90 by 30. So we're going to set that up, that one, and then that one. And we're going to locate that profile based off of where I are. That fella there. So that's actually going to put it just not exactly where we want it. But that's okay. So what we're going to do, this is actually what I was talking about earlier. We're going to edit the sketch on this one. So we're going to set a point there, and we're going to set it in at 15 millimeters. It wasn't actually originally what I had planned, but this is how I'm going to do it now. Obviously, I just sort of wing it when I'm doing videos like this, and when I'm doing things a bit more seriously, I take it a bit more seriously as I'm working. Now, locate profile. We're going to go. Where is it? There it is. There we go. Now, what we're actually going to do there, that was not exactly what I had in mind. Just realised that. So we're going to do another one. And we're going to put that one 15mm off that fella. Now that is going to be constrained vertically, and that'll lock it in place. So if you do that and you lose your model, just hit that fella there, zoom to fit, and it brings it back into view. Oh, I've lost my model part there. There we go. Now we're going to locate the profile again on that one. So we're going to actually inset that. That's not what I want either. Edit sketch. So I'm going to change that to 30mm and hit enter. It'll actually drop it all down. So what we're going to do is have the top slats essentially internally located. So I just want to actually check something before I get too far. So from that one, no, that one to that one is 1000mm. Now we probably want to actually bring that down. So if we're working in 90mm increments, what's that going to be? Yep, that's exactly what I thought it would be. So it's going to bring this down 10mm. And that way what that'll do is actually bring that to an even number. Now the other thing you actually would be worth knowing, you can actually do equations in here. So say I'm working on, about that much per person, do that. Or you can actually do a function, so you can actually do like equals blah 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 blah. For this case, it's going to be 2 meters flat, which gives us a nice size. Alright, now we can hide this sketch because we're finished with it. And we can hide this sketch because we're actually finished with it. Now what we're going to do, normally I would actually base these off the bottom of here, but I figured it'd be easier just to get it going while I'm working. Trim body 1, 2, 3, 4, and we're going to trim it to that face there. So what that actually does is it actually trims it back to a certain reference geometry. You can base this off, for example, your top plane, or you can base it off, a certain face, that sort of thing. If you want to keep certain bodies and you want to trim it, like say for example you want to trim it around these two faces, you can actually set it to keep the top and the bottom, but we're not going to do that. We're just going to trim this flush. So then you've got a basic table frame like that. I've just realised I haven't done that, what I was going to do. So I am going to actually do this the lazy way. I'm going to put in some basic geometry here, and we're going to go like that. And we're going to go like that, and we're going to constrain that to be on that plane, and that'll be our cross member. So I'm going to go structural member, cross there, and that should automatically locate itself. Yep, excellent. There we go. So now we've got a cross member in place. That must be if I'm deleting the sketches by the look of it. If you really want to muck around with the patterning on this, you really can. It's not that hard to do. I do it quite a lot if I'm doing a presentation piece. Alright, so now what we're going to do is we're going to do a normal sketch on this face. And so, because we're going to be working with 90 by 30 on the top, normally I just do this with 90 by 18, but it's just easier to keep working in the same size. We'll base this on the center line, so 45, and then what we're going to do is a linear sketch pattern. That fella there. We're going to go along choose that fella first to make sure we've got the right one. Yep. So we're going to go in the y-axis, and we're going to space these out at 90mm increments, and reverse it, and 11 spaces. Done. Now this doesn't actually tell it what it's doing, so that's coincident, and that will be 90mm, and that'll sort of constrain the rest of it because it's patterned. Here you go. And then the other way you could actually do this, I'll show you both ways. We're going to do that fella there, and we're going to locate him based on that central part there. And then we could also, we could do it this way. So you go, ba, 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 but like that, or what I'm about to do, which is the easier way to do things, is a linear pattern. Now these buttons aren't always standard. I've set these up in a way that I like to work. So with a linear pattern, you can hit that one, and that'll actually use that as a reference. So it's going to tell you which geometry it's going to base itself off. We're going to space it out at 90 mil. Oh, there are 11 of them. Now we're going to work with bodies. There we go. Yes, that's because I've done that silly thing. There we go. And we've got a dining table. So that was, that didn't take overly long. It was 15 minutes, and there's a lot of that was me talking. So normally it would only take 5 minutes or so to do that, if that. Like I said, I've been using Solidworks for quite some time, so I've got quite proficient with it. I'm going to hit rebuild now. If we really want to get into the nitty-gritty of things, I don't know why it's not showing up the grain pattern. But what we can actually do is we can remove that appearance. So we'll keep the material as oak, and then what that'll actually do, that we can look at the approximate weight. So apparently that would be about 62 kilos, which, yeah, it's probably about right. It would be a fairly heavy table at that size. Obviously, if you're going to build this for home use, you would have some sort of way to remove the legs, so you could transport that and then have the legs separate. Alternative, if you were to turn some legs up on a lathe, that'd be different again. But what I'm going to do now is I'm actually going to throw in some special appearance-y stuff. So we're going to work within the wood space here. So this is all found off your side menu. I like the look of rosewood. So the optimal way to work here is to work with the grain. So if you're thinking about how this is actually going to look, we're going to work with similar faces. So you don't actually need to go to this level of detail like I am here, but I'd like to. So selecting stuff you're not actually going to see. So we're going to go with a satin finished rosewood, and then we're going to go anything going this way. So this is all based on what you're going to see. That one. I think that's all of them. Now these ones obviously different because they're going to be slightly different on the grain direction. Actually, yeah, I'm going to add that to it. Now, why did it select that one or that one? Anyway, there we go. Now stuff that's going this way. That one, that one, that one. That one, that one, that one, that one, that one, that one, and that one are going to be polished rosewood as well, satin finished rosewood. And then this one's a bit funny because of the way you have to set it up. So I have to do the front, back, and then the sides of it. And that one again. You have to sort of tell it which way it's actually working. So we're going to do those two. I'm not going to worry about the bottom feet. Alright, so missed one. There we go, beautiful. Right, so this looks a bit funny right now, as you're probably thinking. So what we're going to do is go to Edit Appearance, and we're going to go to Mapping. Now this actually lets us map how it sits. So axis direction, we want to work in the ZX direction. It's getting better. So it actually realigns the plane of direction. We're going to map it at 90 degrees. That's going to bring the grain that way. That's actually looking not far off proper. There we go. That looks a bit more like wood. There we go. Looks pretty cool. All right. Now I'm going to edit the same. That should be pretty easy. That should be just good to go. That one. Now that's going to be running in the vertical plane, so the ZY plane. That looks good. And then we're going to go the same again in the XY plane. Beautiful. Alright. Now it seems to have gone in some weird plane. So we're going to put it in the ZY plane. And at 90 degrees. And small mapping. Now that one's doing some weird stuff. But that's alright for the argument's sake. Let's go. Edit directional light. So now we should get some. Now, see, as you can see, it's all based on that. So it's obviously because I've used the wrong side of the top plane, which I never know is which way to figure out. So I actually put some lights. I use the lights to actually get it to where I want it. This is not actually something you need to do as anything unless you're doing like something specifically for someone who wants this. So we're actually going to bring this into what's called Photo View 360. So we're going to go add in Photo View 360, render tools, and we're going to go like that, and we're going to go like that, and we're going to hit Final Render. I'm going to add on Perspective View from here. Okay, so it's doing its thing now. It actually does like a preview version as well as the full render. So the preview version will actually show in the background, which is kind of strange. I mean, it doesn't look exactly right, but you sort of get the idea. It'll actually show it with a grain. There is actually better, in my opinion, better software out there. Something like Keyshot would do a better job of this. I don't have Keyshot. It's a paid product as well that I just don't have access to. Yeah, so we've made a table. So there's a whole bunch of other things like this. So what I was actually going to get back to earlier is actually showing you how to create a weldment profile. So what we're going to do is we're going to find out where our weldment profiles are so I can show you how to do a custom weldment profile. So in the system options, you want to look at file locations. So all your different templates will all be in here. We're going to go down to weldment profiles, so we are in that location there. So we're going to go to C drive, pull this off screen so I can see what I'm doing. Program files, Solidworks Corp, Solidworks, Lang, English, weldment profiles, AS. And template profiles, I'm going to copy and paste that file location so I can show you this. So I'm going to go File, Open. Okay, so, excuse me, the file location for these is, so if you want to add them to your Australian standard or your ANSI standard or your DIN standard or whatever it might be, so HFS5 is some aluminium extrusions that I put on there. T-slots is other stuff I put in there, which I haven't really. I know this is actually stuff I do have access to. Excellent. So as you add different weldment profiles, they'll all end up in here. So I'm actually going to leave it for now. So I only work in AS stuff because I work in Australia, obviously. And so this has got all your standard stuff. So as you can see, there's template profiles. I haven't touched it for a while. So we're going to open, let's say, that one. So I know as a matter of fact I can get 65 by 32, I think is the correct size. So what we're going to do is we're going to save a copy. So this is the strange part. You actually need to save this to your desktop. That there is the profile, the testing stuff for your CSWA or CSWP, which I've been using. So I'm actually about to do my final CSWP one to get CSWE, which is quite exciting. So what we're going to do is save this as 65 by 32, and it saves it as a library feed part. 65 by 32. Save as copy and open. And now we can close the 65 by 12 version, and we can edit that sketch. Now change that to 32, hit OK, you can save it. Now if you don't have access to these, for example, what you can actually do is pull them out of a different folder. So for example, we can pull one out of 380 PFC, read-only, which will become the default thingy. So what we do there, so it's parallel flange channel. Discard changes. You can do the same thing, so you can actually save this out as what you want to call it and build your folder structure as I have. So we'll go through that in a minute. So we've saved that. What we'll now do is we'll cut that, and we'll go to, I'll go to my weldments folder again because I've got that as in my clipboard. Program files, SolidWorks Corp, SolidWorks, Lang, English, weldment profiles, AS, and timber profiles. And we're going to go Control V, and we'll say continue. So now we have that in the folder. So now if we go back into SolidWorks and we go new, what we can do is sort of a quick sketch. Top plane, sketch. I'll dimension it so it's not something silly. Now we can go down to timber profiles, and there he is. So some of the standards might actually be missing certain things. I know some of the Australian standard stuff is actually missing from the Australian standard stuff. So certain sizes of pipe are actually missing, so you may have to go through if you need them and actually sketch them and put them in the same way. Another thing to note when you're working with weldments, if you want to do a square, always work in sequence. This is just something I've picked up as I've worked. So if I go like that, then that, and then that, it won't actually let me do it. So the key here is to work in sequence of or at least work to the next member rather than working for the members in the same direction or something. So if I wanted to do that as like a butt joint frame, I could do this way. There's more than one way to do this, but that will actually expand that out to that. The other way to do that, obviously, is you can do, well, obviously for me, so what you can actually do is click on that. So what this brings up is the corner treatment thing. You can actually choose which way it trims it. So you can go miter join, you can go end butt and end butt. So if we want to do the same at this end, so click that one, and you do the same again. So you expand it out, so you just choose whichever one looks the way you want it to. I personally prefer to work in miter joins, just as a preference when I'm working. If I'm building something, just so I know it's a bit stronger. That may not be true, but I feel like it is. If it's going to work like this, I would do pocket hole screws. So that one is going to be like that, and then that one is going to be like that. And there we go. So hopefully you've learned something from this. There's a lot of other stuff that I'm quite happy to show people or to work through, stuff like sheet metal, stuff like other weldment stuff, best practice within design space, that sort of thing. So if you have any questions, just leave them in the comment and I can address them there or make a video about them. So yeah, thanks for watching.